Hello friends, this is Bharti and you are watching Learn Maths with Bharti. So today we have a theorem, Basic Proportionality Theorem. Basic Proportionality Theorem. It is also called THALES Theorem. So today we have to state it and we have to prove it. What is the statement? Let us read. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. It means if a line drawn parallel to one side of a triangle. So we need a triangle. First, we will draw a triangle. Let us name it A, B, C. Then if I again read, if a line is drawn parallel to one side of a triangle, if a line is drawn parallel to one side, let us draw a line parallel to BC. Let us a line drawn parallel to BC. Suppose we draw a line parallel to BC. Suppose this line is DE. Suppose we draw a line DE parallel to BC. So again, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, it means let us draw a side parallel to BC and it intersects the other two sides in distinct points. Here, this line intersects AB at D and intersects AC at E. Then this much is given. Then we have to prove that this line divides the other two sides in the same ratio. It means AD by DB is equal to AE by EC. So here first we should write given. What is given to us? Given triangle ABC, DE parallel BC. This is given. So we have to prove. To prove. What do we have to prove? To prove. What do we have to prove? We have to prove AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. AE by EC. So let us move to next slide. So here we have to do some construction. Join BE and DC. Join BE and DC. And draw perpendicular. Draw EN perpendicular to AB. And DM perpendicular to DM perpendicular to AC. DM perpendicular to AC. This is our construction. Now let us start proof. So we will start proof from here. First we will find the area of triangle ADE. In triangle ADE, we have, what is the base? We have base AD and we have the height EN. So, area of triangle ADE is equal to half into, what is the base here? AD. And what is the height here? EN. Now, area of triangle. We will take this triangle BDE. BDE, half into base. What is the base here? BD. And what is the height for this triangle? EN. BD into EN. Have you understood this point? Why for this triangle height is EN? Do you remember in your junior classes you have learned that suppose if it is a obtuse, if it is an obtuse angle triangle. This angle is obtuse. For this triangle, suppose it is a base, then what is the height for this base? So extend this base, then draw a perpendicular from this vertex. You will get this as height. So this is the height. So we will get the height for this triangle. We get the height outside for this triangle. So here for this triangle, En is the height. We get the height outside of this figure. So here what is the area? Half into BD into En. Clear? I hope it is clear to all of you. Okay, now let's move ahead. Now let us take ratio of triangle, area of triangle ADE, by area of triangle BDE. So here half into AD into En by half into BD into En. So En we can cancel it, half also we can cancel. So we'll get AD by BD. Now let us find out another time triangle, area of triangle ADE, But this time we will take the same formula, half into base into height, but this time we will take AE as base and DM as height. AE as base and DM is height. Now area of triangle, now we will take this triangle DEC, triangle DEC. So same formula, half into base. What is the base for this triangle? EC. And the same concept here, what is the height for this triangle? We will get the height outside. So DM. So here also we will take the ratio. Area of triangle ADE by area of triangle DEC is equal to half into AE into DM by half into EC into DM. Now see, here DM cancel, half cancel. We'll get AE by EC. Now let us name it equation number 1 and name it equation number 2. Now observe these two equations. Now once have a look here. We have to prove AD by DB is equal to AE by EC. Okay, we have to prove AD by DB is equal to AE by EC. See, if you see right hand side of these two equations, AD by BD, if we prove that AD by BD is equal to AE by EC, it means the proof is over. Okay, to get these two equal, we need to prove left hand side are equal. It means if this side and this side, okay, left hand sides of these two equations are equal, then we can say that right hand side also equal. But here numerator is same. See, here triangle ADE, triangle ADE, but denominator is different, triangle BDE, triangle DEC. But here if you observe that triangle BDE is this one and triangle DEC is this one. These two triangles are on the same base. See, DE, this is the same base. Okay, here I will change the color. Once see, here DE, see this yellow line, DE is the same base for these two triangles. Triangle BDE and triangle DEC are the same base, which is DE, and DE and BC are parallel lines. These two triangles are between same parallels and on the same base. So area of this triangle will be equal to area of this triangle. It means If area of this triangle and area of this triangle are equal, it means here denominators are equal. It means here denominators are equal. If the denominators are equal, then it means in both the equations, left hand sides are equal. It means automatically the right hand sides will be equal. So we will write here. We can see that triangle BDE, triangle BDE and triangle, which triangle? Triangle BDE and triangle DEC. Triangle DEC. Triangle DEC are on the same base and between the same parallels. So area of triangle BDE is equal to area of triangle DEC. It means, so we can name it equation number 3. Now from equation number 1, 2 and 3, we can say that, see, from 1, 2 and 3 we can say that left hand side will be equal, so right hand sides are also will be equal. Therefore we can write that AD by BD is equal to AE by EC. So hence proved. See, we need to prove this one only. See, AD by DB is equal to AE by EC. So we have proved it. AD by DB is equal to AE by EC. I hope you have understood it very well. Thanks for watching.